I'll be covering vision systems, also known as optical comparators. Optical comparators are devices that can visually measure and inspect components. This technology was first developed in the 1920s for checking screw threads, and the original units were huge. The concept has not changed over the years and is very similar to an overhead projector. The component is loaded, light is shined through and around, projecting a silhouette of the part onto mirrors through a precise magnifying lens and onto a viewing screen. Traditionally, this viewing screen had transparent rulers or transparent CAD models, and you were literally comparing your part. Nowadays, the devices are a lot more compact and can fit on your desktop. They are in the vertical orientation, and technological improvements to optics and integrated software have been applied. These are two examples of optical comparators I have worked with. The video on the right shows the modern one where I am measuring a padlock. This device has a digital video output. Here I am selecting a length dimension where I draw a very unstraight line, followed up by another not so great line. You can see the line detection software corrects my lines and spits out a dimension. Next up, I am measuring an inner diameter, and the device is able to quickly calculate that. Capabilities and benefits. It's quick with little to no fixture setup. It's more efficient than using multiple hand tools. There's very little skill needed, so there's little training needed. It's easier than hand tools. And if you have delicate or soft parts, measuring visually is the way to go. There are limitations. At the end of the day, you're measuring 2D silhouettes, so you're not going to be able to measure every single geometry that's out there. I have the perfect case study. There was one time where I was trying to measure this inner diameter that was wider than the opening of the part. And if you can visualize the light from the comparator shining down through the part, it's only going to cast an inner and outer diameter. So it was very limited and had to measure with a CMM here. Also, from the bird's eye view, if you have metallic shiny parts, sometimes it's very hard to see where an edge starts. Economics, your comparator is going to be more expensive than hand tools, but a lot cheaper than the CMM. You're not going to spend on tools and probes that are breaking because it's a no contact form of measuring, and you're going to have little to no spend on operator training. Further applications are around component detection in manufacturing, so you can set up your vision system to detect if screws or cables are missing, if cables are unplugged, and you can also have high-speed conveyor belt inspection. These are my sources.